So this is the complete binary tree, and which is used to form a heap. So heap is kind of a complete binary tree. Okay, is a kind of a type of a, except the last level leaf over leads towards left. Correct. Okay, so it's kind of a complete binary tree. Okay, so it's type of complete binary tree. Okay. Now there are two types of a heap. Okay, so there are the two types of the heap. One is called the max heap. Okay, another is called min. Okay, now what is a max heap? Okay, so the max heap, all the value at the root node or at the parent will be greater than its child. Okay, now see, this is 100. Okay, its child is 40. Okay, and 60. See, both the childs are smaller. Okay, now this should be same or for its subtree also. Okay, this subtree should also be a heap. Okay, for heap property to follow, it to be a max heap, the parent should be greater than its child. Okay, so it's, if it's 40, right, so it could be 10, it could be 30. Now for 60, it can be 50, it could be 30. Okay, now see, for all the levels, so this is heapified, right? So 10 and 30 both are less than the parent, 15, 60 both are less than the parent, and 40 and 60 both are less than the parent. So this is called the max heap. Simple. Now in the min heap, the value at the parent should be smaller than its child. Okay, so here we can say greater than child. Okay, in case of a min heap, the parent should be smaller than child. It is like this way, 10. Okay, its child is 20 and 40. For 20, it's 40 and 30. For 40, it's 50 and 60. Okay, so this is, each of the child is greater, or we can say parent is smaller than child. Each of the parent is smaller than its child, like see, 20 less than, 40 less than. So this is called the min heap, right? So there are different use cases for the min heap and the max heap we have. Now the next thing that comes here, what is the operations that can be performed here? Okay, so one thing that we can see here is insertion. Okay, we have to analyze like insertion, right? So inserting a node, we can insert a node in this heap, right? We can insert any node in this heap, and if you see, like, we can insert a value which could be greater, which could be smaller, right? So we can insert into the heap and then do some operation, okay, to make it a heap again. So insertion is possible, deletion is possible. Now in deletion, there could be like, we can delete any node, okay, or you can say you can delete the top, extract min or extract top node. Okay, we just remove this node or any node. So this is called the type of a deletion here we have. Okay, now we can get the peak or the top element. Okay, now the fourth functionality could be it will be a heapify. We'll discuss what is an heapify. So heapify is just basically balancing the tree to make it again a heap. Okay, now for all these operations that we discussed, okay, the insertion, deletion, whatever operations we discussed, right, this peak, this is like just getting the top element, so this is big O of 1. For insertion, as it's a complete binary tree, so we can simply insert any node in big O of n. Okay, in case of deletion or anything, it's big O of log n. Sorry, log n I was saying, not the big O of n. Okay, big O of log n. So each and every process, insertion, deletion, heapify, everything takes big O of log n time complexity. Okay, so these are the operations that we perform on a heap. These are the two types of the heap we have, where the min heap and the max heap. Max heap will have all the parent is greater value than its child. In case of a min heap, the parent will have the smaller value than its child. So this is introduction of a heap. Okay, now if we talk about the array, okay, if we talk about the array, so in array we already discussed when we were discussing the binary tree starting, right? So we already discussed, if you want to save the nodes in the array, okay, then to get the left child, the position that we have to go for ith node is 2i plus 1 for the left child, and for the right one is 2i plus 2 to get the right child. Okay. Now for parent, it is I minus 1 by 2 to get the parent node, where the parent node lies. Okay. So this is what we have to do for ith node. Left child will be at 2i plus 1 in the array, right child will be 2i plus 2, and parent will be I minus 1 by 2 to get the parent here. Okay. So this is what we have. Okay. So if we have 4 here, okay, 5 and 6 here, and 8 and 12. So what will be the heap 4? Left is 5, that is 2i plus 1, right 2i plus 2, correct? And for this, it's 8 and 12. Okay, so this is what we have, a heap, and these are the positions where they are storing, right? So for this position, if you see I equal to 1, right? So its child will be at this position and at this position, which is 0, 1, 2, 3, that is 2i plus 1, and 2i plus 2, that is 4. Simple. Okay, so this is the left, right parent, and this is the heap node. Simple. Now we discuss like what are the operations are there, right? So we'll try to understand, like we will try to implement those operations that we have here in the heap. So one thing that we have is the insertion of any data, then the deletion of any data, then the heapify. Heapify is basically the balancing the tree. Okay. Now the next thing that comes here is how to create a heap. Okay. One of the array is given to you. Now you want to create the heap. So how you can create the heap? That's the next question. Okay. So consider one array is given to you. Okay. And now you have to convert that to form a heap. Okay. So let's take an example. So consider any array which is not in the sorted order or something like that. Okay. So consider array given to you is 4, 10, 3, 5, 1. Okay. So this kind of an array is given to you, which is a tree also. Now we have to heapify that tree. 4, 10, 3, 5, 1. Now we want to find the max heap. We want to form the max heap from this tree. See one thing, is it a max heap? No, this is not a max heap, right? So how to form it a max heap, right? So there is an operation which we have to perform to form a max heap, right? So there is an operation to perform which is called heapify. Okay, so heapify is basically rearranging. Okay, you can say heapify is basically the rearranging the nodes, okay, in some order, okay, so that they will always be in the heap. Okay, so consider we added so there would be a one possibility, like we have a tree and we just heapify it, or you just insert it. So you insert 4 in the heap. This is heapified, right? Now you insert 10. So it's a complete binary tree. So first we'll fill all the levels, like so it will be inserted at 10. Now for 10 we check, is it a correct for the max heap? No, this is not the correct. So we will, what we'll do, we will reverse it, that is 4 and 10. Simple. Now we insert 3. So after inserting 3, we check with the parent. Okay, parent is greater, then it means the node we inserted is correct position. That's fine. That's fine. Now for this we inserted 4 and 3 was already there, right? So now we inserted next one, next node is 5. Now for 5 we check the parent node. The parent node is smaller, right? But it should be greater because of max heap, right? So we just swap it. The 5 will come here, 4 will come here. Okay. Now for this node also, we will check with the parent. If parent is correct or not, okay, parent is correct, then just ignore it. Move on to the next one. Okay. Now consider this was 11. Okay. Consider this was 11. Now we add 11 here, right? So once we add 11, we compare with the parent. Parent is 5, which is smaller, right? But it should be greater. So it will be like this. We just copy 11. 4 was here. Okay. 5 comes here, and this. Now, once we swap, now for this node, we have to compare with its parent. So compare 11 with its parent. It is again less. So it will this will come here. This will come here. Now it is a final heap. If you observe 11, both are less. 10, both are less. So this is a final heap. So while inserting any data, you have to perform heapify. Okay, which is called bottom up. So you are going from the bottom, right? So you are going from bottom. So this is called bottom up heapify, or name could be anything, right? Bottom up, heap down, or heap up, or the bubble up. Okay? So it's kind of a bubble up we have. Whatever node we inserted, we bubble up that node to the correct position. This is called the bubble up or bubble up heapify. Simple. Okay.